Hello, this is Raf Alvarado. Welcome to Exploratory Text Analytics. Today we're going to do what we did last time. We're going to import Persuasion into a data frame and then tokenize it. But we're going to do it in a more sophisticated way. And we're also going to do it in a way that shows how we can operationalize the concept of OCO, or Ordered Hierarchy of Content Objects, which we're going to be using throughout this semester. So let's get started with this process, which, by the way, is a pattern that we're going to use and generalize to a broader variety of texts. Okay, so like last time, we're going to set everything up. Here I'm doing a little more structured configuration. Variables up top, I'm defining a data home. This is a directory where I'm going to be putting source files and outputting the products of our work. On your computer, you may put these in a different place, so you will probably want to change data home if you copy this notebook and use it. Then we're going to define our files. Text file is the source file, which is what we used last time. PG105 is the Gutenberg version of Persuasion, and then we have a CSV file, which is what we're going to output. So one of the patterns that we follow in this class is that we do analytical work, and then we output the results into CSV files, but these files are designed so that they can be ingested into a database and treated as one set of interconnected set of tables. But right now we're just working in this one CSV file as output. Next, we're going to define our Ordered Hierarchy of Content Objects, or OCO, and this is a list that defines the sequential order of the elements in our document structure. And we already know this ahead of time. Different documents have different structures, but pretty much when you're looking at novels in Gutenberg, they have this structure. This is all we're really going to care about. Chapter number, which is the chapter, of course, the paragraph, the sentence, and the token. Okay, there are other ways of slicing a text, like there are volumes and things like that, but we're not going to worry about those. So here's our OCO. We're going to use this throughout the notebook to help us define the index and to select our elements of our data frame using that list and slices of that list. That'll all become clear in a second. So we're going to do the same thing we did before. We're going to import our text as a group of lines. This time we're going back to using read lines because we're going to use a different method to chunk the text by chapter than the one we did last time, or rather than by paragraph. Last time we used a double new line, but what we did when we chose that method is we skipped over chunking the text by chapter, and we want to do that. So I'm going to show you a different method, more sophisticated approach this time. So also what we're doing is we're putting this open function directly as an argument in the data frame constructor for pandas, just not wasting a variable there. That's just going to be used for the argument for the next line, so we're just putting it right in. Another thing is that there is an encoding argument that we're adding. This is because files from Gutenberg we have found are encoded in a UTF encoding that add this weird character in the beginning, and we want to strip it out. This is as a side, we're not getting into character encoding in this class, but it is a really important aspect of text analytics, because when you're importing text from a variety of sources, it can be encoded in different formats, especially when you're talking about different scripts. Nowadays, some sanity has been introduced into character encoding because we have a standard called UTF, which encodes 16 million character types, whereas in the old days we had something called ASCII, and it had to be reproduced for different languages. Long story. We're not going to go into it in this class, but occasionally you do have to think about it and add a line such as we have here. So we're going to take this data frame, we're going to name the index like we like to, and then we're going to strip out, right off the bat, we're going to strip out new lines because we don't need them. We're doing a different method in this notebook to parse the text. We're going to get rid of new lines because they're not helpful information for us. So here's the result. I'm going to sample the results of this. It's just like we did last time. It's a set of lines. I have this in here. It's not important. You can do this if you're working with a corpus of text and there is a predictable way where metadata lives in the text, such as a title, then you'll do something like this. Just imagine you're going through an entire directory of Gutenberg text. It may be the case, and I know this is not entirely true with Gutenberg, but it may be the case with the set of files that you download from them, that they all have a line that says the Project Gutenberg ebook of, and you can assume that the title follows. The trouble is, not everyone enters data in the same way on Project Gutenberg, and so your mileage will vary. But here I'm just showing you this just kind of for the heck of it. We're only doing one file, so it's not super important. We already know the title of it. Now we're going to clip the cruft of this text. This is where you take, we realize that the source text has a lot of front matter and back matter, a lot of boilerplate relating to Project Gutenberg that is the same for every file, and we don't need it. It's not only unnecessary, but it actually will distort the data that we import, because we want to import the text itself because we want to make observations about the text, which is an historically specific and culturally specific production that has nothing to do with the modern boilerplate of Gutenberg. So what I'm doing here is I'm creating a list. It's a 2-element list of 2 regular expressions, one of which defines lines that exist in Project Gutenberg files that mark the start of the text, and a line that marks the end of the text. And we're just going to take these patterns, clippats 0 and clippats 1, and match them using the match method in the string package on pandas applied to this line string column. And from there, we're getting a Boolean list of true and false statements, and presumably the first one is going to return a list in which only one row has a true value, and the same with the second one. And that true value will be where that line exists. So we take pattern A and pattern B, and we pass it as arguments to the lock selector in a data frame. And we're going to, from that data frame, this is going to pull out one row, and what we want is the index name for that row, because that's the line number. And then we're going to increment it or decrement by 1, because we don't want the line itself. We want, for the first line after the Gutenberg line is what we're interested in, and the line just before the ending line is what we're interested in. That's why we have plus and minus 1. Here are the values of those. So the text begins on line 19 and ends on 8372. So now we're going to use those to get a slice from our data frame. This is a convention we can use from some number to some number. That's an index value, that's an index value, and using a colon means we're getting a slice. And so now our lines data frame is reduced to having it just being these. It's starting at line 19 now. We could reorder that if we want to, but we're going to get rid of line number anyway. It's not a useful, it's not structurally interesting for how we're working with our text. We're just going to leave it like this for right now. You can see that the beginning of the text now has still has some front matter that we might want to get rid of, and that the end of the text still has some back matter that we might want to get rid of, but we're in a better position. And we're not going to worry about these little bits of text right now. Okay, now let's get into the important part here of chunking the text by chapter. This is, our first content object that we're interested in representing. The highest content object actually is the novel itself, and so if you're building a collection of novels, that will be the first element of your ordered hierarchy of content objects, the book. But we're working on a single book, and so our first element of the ordered hierarchy of content objects is going to be the chapter. So how do we chunk this text by chapter, right? Well, we know that if you look at the source file, you have these standalone lines in the source text that say chapter 1, chapter 2, and chapter 3, and so forth. And so in this particular text, and sometimes there's some letters as well, and they're listed as letter as a header, standalone. And so what I'm doing here is I've created a regular expression that I'm hoping will identify all of those lines in the text that are headers for chapters, okay? And so I use that, and I'm going to call my match operator again, method, and I'm going to pass this regular expression, and it's going to again return a truth vector, and it'll be true for any line where this pattern exists. And so I'm going to take that and pass it as an argument to the lock selector, and now you'll see that the result is that yes, in fact, there are 24 chapters in the book, and it captured all those line strings perfectly, and it's not missing any. So that's nice. I actually didn't need letter in there because it's that's actually a more general pattern, because some other books have letters. This one obviously doesn't. So here we go. I've got all the chapter headings. Now what do I do with that? Okay. Well, the first thing I want to do is I want to create a new column, because what I'm just to jump ahead here, I'm going to create a new column, and that column is going to have the chapter number not only for the chapter line, but for every piece of text that follows it, so that every piece of text is identified with the chapter. So the first step in this process is to just create a new feature and convert this this textual naming convention into a numeric one. These should be integers. We can change those to integers later. For some reason, Pandas likes to default to floating values in some contexts. But you can see right here, all I'm doing is I'm creating a new feature called chapter num, and I'm passing it a list that is as long as the chapter line subset of this data frame. And so it's basically passing, adding this value 1, 2, 3, and 4 to those lines that have a chapter, but it's null everywhere else. And in fact, let me, here you can see, if I sample the text, you find in chapter num a bunch of null values, and this is the content itself. That's because these lines are not chapter headers, right? But what we're going to want to do is fill these values with the numbers of the chapters to which they belong. So it turns out there's a really convenient way of doing that in Pandas. It's called forward fill, right? Ffill. It's a really nice little method. So what we can do is take chapter number, and what it's going to do is go through the data frame, and anytime it finds a number, it's going to fill in any following null values with that number until it gets to another number that's set, and then it's going to do the same with that number. And that way, all of our lines now will be associated with the chapter. So that's pretty cool. You can see here, if we look at the head of our text, we have a bunch of nulls, even though we did this operation of substituting nulls for ones. And the reason this is because these are all things that precede chapter 1, and effectively we're going to get rid of those. We don't need them. All right. Okay, so here we go. How do we do this? Well, the first thing we want to do is we're going to drop the column that existed with chapter num. We're going to drop any nulls that are in the column chapter num. This is what drop NA does, means drop any null values. Subset means you're telling the method to only look in a certain column for null values. And so we're saying any null values in the chapter number column, just get rid of. And what that's going to do is remove everything before chapter 1. This is another way of doing it if you care to look at that later. And then we're going to remove the chapter heading lines because we don't need them anymore. So you'll notice as a result of this operation, we now have a chapter number column, and it's nice and filled out with numbers. And then we still have a chapter title. We still have our chapter titles in the text as line strings that appear, at various points. But we don't need those anymore because the work of that header is done. It's been converted into a column now. And so we're just getting rid of them. And now we've neatly identified every line in the text with a chapter number. Now here's an important pattern that we're going to be using throughout this semester. Let me get rid of the scrolling there. Is we're going to take a slice of our OCO and use it to group our data frame. Because what we want to do here is take our data frame and we want to group it by chapter number, okay? And then we want the chapter number, all the lines associated with the chapter number to be concatenated into a long string, all right? And then we want the chapter number to be the index, right? This is our first move here after identifying lines with chapters. So this is done by the group by function. You can see that I'm calling lines, and then I'm grouping it by chapter number, which was a column we just created, and which is also the first value in our OCO list. And then I'm going to apply to each string this function, this lambda function, which is an in-place function we define to operate on each line, each row of our data frame. So if each row of our data frame that share the chapter number, those become subgroups, we're going to join all the lines for each chapter number. And so we're going to join them by a new line, and we're going to form chapters out of them, whole chapters, and we're going to preserve the new lines because that's going to contain information. Those double new lines are going to be useful. We saw that they're useful for separating chapters, so we want to hold on to those new lines, and we're going to have a big chapter string for each chapter that's going to consist of some new lines that are single. We're not going to worry about those. We're going to strip those out later. But some new lines are going to be double, and we're going to keep those. All right, we're going to use those as information. So now we have a chapter, a data frame of chapters. So each row is a chapter, and we have numbers in the index column, and each chapter string column row has the full chapter in it. You'll see that there are line breaks in there, and we're going to work with those later. Here we're calling the strip function right before we get into any more further processing, which removes any white space, and new lines are considered white space, before and after the string that is our chapter. So anytime you pass strip to a string, it's going to basically clean it on the ends. It doesn't do anything to the inside. It just removes from the ends any white space. So now we have some nice full lines, and you can't see the rest of it. These are actually pretty long. Now we're going to split this into paragraphs, and we're going to do what we did before. We're going to use the double new line as our pattern. Okay, and so what we're going to do is the same trick we did before. We're going to split each chapter string by this double new line, and we're going to use the expand equals true, and then we're going to stack again like we did last time. We're going to convert it to a frame, and we're going to sort the index right after we do that. This is something, it's kind of like good housekeeping with pandas. It's often helpful to sort your index after conducting an operation because it helps with other things, and it's a little bit of another topic that we won't get into. But just realize that you should be, after an operation like this, you should sort your index. Now I'm going to call this second column that I just created, which wasn't named before. I'm going to call it OCO a paragraph number. So calling it, using paragraph index names OCO :2 means use the first two elements of the OCO list to be the names for the index we just created. All right, so now we have a well-named index, and you can see that it represents the structure of the text. You've got chapter 1, and in each chapter there's a series of paragraphs. And we have a paragraph string column which describes that. Okay? Now we're going to strip out the new lines. We don't need them anymore, right? And then we're going to do strip like we did before, just in case there's any cruft at the ends and the beginnings of paragraphs. And we're also going to remove any empty paragraphs. So if there are artifacts left of just rows without any content, and that happens sometimes, we're just getting rid of them. Okay, so you can see what I'm doing here is I'm matching all white space, and I'm using the negation operator to say that I only want paragraphs that don't match this condition. Okay, there are many other ways of doing this. This is just a simple way. And now we have this as our result. Okay, now we want to keep marching down to the level of the token. So the next level is the sentence. Remember, the sentence is crucial in understanding text, because text is discourse, right? And discourse, the unit of discourse, is the sentence. The sentence is absolutely important for all kinds of things. It's important for grammar. Remember, grammar describes what happens in sentences. not what happens above sentences. We don't have grammatical concepts for relating sentences. There's stuff like co-reference and things like that. But grammar essentially refers to what happens inside of a sentence. And what happens above a sentence is another domain of linguistics and of textual analysis. And that's actually, we're getting to the domain of sociolinguistics and literary criticism, narratology, and things like that. So we're going to want to capture the sentence because a lot of our operations are going to work at the sentence level. And that's super important. Our language model, for example, which we're going to get into next week, works at the sentence level. All right, so we're going to define a pattern, and here we're going to just to point out to you, we're using a heuristic pattern for our sentence. It's just, we're going to assume that any period, question mark, any punctuation of this kind, and I'm defining a character class in this regular expression, is going to separate a sentence. This turns out to not to be entirely accurate because we have in English the convention of what do you call it? Of abbreviations having periods, and that breaks the model. I'm not going to worry about it at this point because when we get into natural language processing tools like NLTK later, I think in 2 weeks, we'll have a more sophisticated way of predicting sentence boundaries, because sentence boundaries are a little bit difficult. So we actually need a model to predict them, and we want to pull one off the shelf since they're kind of hard to build and train. But here we're just going to use a simple regular expression to do our work. And then we're going to do the same thing. This is a pattern you can see. We're splitting and expanding and stacking. Split, expand, stack to frame and so forth, and then giving index names. And as a result of this, very same sorts of things. We're cleaning up, we're removing empty content, we're stripping. Now we have expanded our index into 3. And we're almost done because we want to get into tokens. But you can see we've got chapters, paragraphs, sentences, and then we have sentence strings. Okay, now let's get into the tokenization, which is what we jumped to last time. So last time we did this very simply. We went directly to paragraphs, and then we went directly to tokens. But we skipped a step in each case. Now we're doing chapters, paragraphs, sentences, tokens. So within each sentence, we can apply our splitting operation here. And we're going to do a little bit more sophisticated of a regular expression. We're not just going to split by space. We're going to split by spaces, which is what that s slash lowercase s means, anything that's a space. And also single quotes we're going to use. And we're going to use commas. And we're going to use dashes. Now, you may think, okay, we don't want to split by treat a sentence as with a comma. And you're right about that, because in many cases, a comma is, denotes a series of things, not a, excuse me, we're talking about tokens. Oh yeah, so scratch that. I thought we were talking about sentences. We're talking about tokens here. So yeah, clearly commas are an important part of splitting. And also, but I guess the more controversial thing is the dash. So you may think the dash actually shouldn't separate a token. Or the apostrophe shouldn't separate a token, but I'm making the argument that it should, and whether it's right or wrong, we can go into the details about that. It's just a decision we're making, a hyperparameter, if you will, going forward, and we can revisit that. Okay, so now I've taken the token pattern, doing the same thing. I'm splitting, expanding, and stacking. I am now using the entire OCO to define it. I could have just left that without the 4 there because I think it's only 4 items long. And now we have our tokenized table, but this time it is fully articulated with an ordered hierarchy of content objects. Okay. Now the same thing we did last time. We're going to extract a vocabulary, so I don't need to spend a lot of time on this. We're going to use the value counts operation to pull out our vocabulary, and we're going to. This time we're going to keep the result of value counts and have well, actually we did last time I think as well. We had n in there, which is just the frequency of the term string. And now, so that we're done, that we've tokenized the text, we've got a fully articulated ordered hierarchy of content objects, and the last thing is to actually provide a method that puts Humpty Dumpty back together again. You may be interested in reconstituting from your token table paragraphs, sentences, chapters. And so here's a method to do that. You basically pass the OCO level that you're interested in reconstituting, and there it's defining globally the tokens table that we created. And this operation does that. We won't go into detail about this because this is just something you can just use. And in point of fact, this entire process I've wrapped up in a library for you that's much more general, so that you can just pass a Gutenberg type text to it and just run the library to tokenize it. But I want you to see this process, because it's very important to understand how a text is tokenized, what decisions you're making at each point, and which ones are basically hyperparameters that sometimes are just buried in the tool that you're using. Okay, so now we have, I just decided to gather it by level 1, which is chapter, and you can see I've got my chapters. One thing that we're not reconstituting here, and this is a design decision that we could make further upstream, we're not reconstituting punctuation. So it's not lossless. We could have constructed this in such a way where we capture punctuation as well as tokens, but we're not doing that. And so this is what we end up with. This is useful for not reconstituting the text for reading, but reconstituting the text at various levels for certain kinds of operations. For example, as we're going to get into, topic models work better with paragraphs, sentiment analysis works better with sentences, and there are certain operations that work better with chapters. And so here I am gathering paragraphs, here I am gathering sentences, and so forth. And now I'm saving my work to a CSV file. I conclude here with a version of the whole operation conducted using a class I created called text importer, which I can provide to you if you want to use that. All right, so let's go to